instructions we used in these programs. We have 3 types of instructions in C, of which the type declaration instruction has already been discussed in the previous video. Now, let's discuss arithmetic instruction. The first question is what arithmetic instruction is used to perform arithmetic operations between constants and variables. Or we can say that used to perform mathematical operations given below, such as addition, subtraction, etc. For example, sum equals a plus b, or multiplication equals a multiplied by b. Let's now discuss the rules of arithmetic instruction in C, and how we can write correctly. Though arithmetic instructions look simple to use, one often commits mistakes in writing them. Let us take a closer look at these statements. Note the following points carefully. Point A. C allows only one variable on the left-hand side of equals. That is, z equals k multiplied by l is valid, whereas k multiplied by l equals z is invalid. B. C also provides a modular division operator. This operator returns the remainder when one integer is divided by another. For example, 10 divided by 2 equals 5, whereas 10 modules by 2 remainder 0. The modulus operator works only with integers and cannot be applied to a float, and the sign of the remainder is always the same as the sign of the numerator. The next point is how the character is used with operators. If characters are used with an operator, then their ASCII value is used as shown below in the table and example. You can see in example D that arithmetic operations can also be performed on characters with the help of ASCII values. As we see, an ASCII value is 97 and B ASCII value is 98, therefore, Z value is 195. Next point E, here you see the difference between how it is used in general math and how we can use a C statement. We use a star instead of a dot. In high-level languages, C also does not have an operator for exponential power. Therefore, as you see below, star and power are invalid operators. But if you want to calculate exponential power, you need to use the power function. Power function is a math.h library function that you can use for power calculation as you do here. When talking about integer and float conversion, to effectively develop C programs, it is necessary to understand the rules for implicit conversion of floating point and integer values in C. These are listed below. Note them carefully. An arithmetic operation between an integer and an integer always yields an integer result. See the front figure, and so on. An operation between a real and a real always yields a real result. An operation between an integer and a real always yields a real result. In this operation, the integer is first promoted to a real, and then the operation is performed. Hence, the result is real. Let's discuss type conversion in assignments. It may so happen that the type of the expression and the type of the variable on the left-hand side of the assignment operator may not be the same. In such a case, the value of the expression is promoted or demoted depending on the type of the variable on left-hand side of equals. Here in the first assignment statement, though the expression's value is a float, 3.5, it cannot be stored in I since it is an int. So I get 3. In the second assignment, 30 is int but b is float. Here, int is promoted to 30.0 and the stored, so b gets 30.0 float value. See example 2. Some operands are ints, whereas others are floats. During expression evaluation, the ints would be promoted to floats. Therefore, the result of the expression would be a float. But when this float value is assigned to s, it is again demoted to an int and then stored in s. Let us observe the result of the arithmetic statement to understand clearly. Follow the steps given below. The statement k is an integer variable and a is a real variable. Evaluation of both 2 and 9 are integers. Result before assignment, 0. Value stored in k is 0. Therefore, the result is 0, which is assigned to k. And see case 2. The 9 is promoted to 9.0, which is a float, and then the division is performed. Division result is 0.222222. However, this cannot be stored in k being an int. Hence, it gets demoted to 0 and then stored in k. In summary, if we discuss, int to float promotion is automatic and safe, but float to int demotion loses the fractional part. In expression, if any operand is a float, then the result becomes a float. For assignments, the result type depends on the type of the left-hand side variable. Thanks for watching the video.